Hello, we are going to go over attributes and transformations of exponential functions. So we will talk about the key attributes of an exponential function and identifying and graphing the transformations of an exponential function from the parent function. So starting out, we've got our attributes. So domain is how far left to right the graph goes. Range is how far up and down the graph goes. So with domain, that's going to be all of your x values that this curve covers. So how far side to side, what x values all the way to the left, what x values all the way to the right. And then range is similar but for y values. So we've got our y-intercept. And we have our asymptote. So remember that your asymptote is like an invisible horizontal line that your graph, this line, cannot cross and it cannot touch. And then as for the x-intercept will depend on where we have our asymptote. In general, we have this exponential function. So this is where we're seeing those basic growth and decay functions. We haven't quite gotten into transformations yet. So an exponential function is called an exponential function because x is in the exponent spot. It's in the name. A is our starting value. And so I'm going to put a label on this. It is also the y-intercept of this basic function. So if you just see something in the form of ab to the x, then know that that front number, the a, is going to be the y-intercept of your graph. B is going to be our growth and decay factor. So we're going to go into that a little more on the next slide. With exponential growth versus decay, we of course only get it with an equation in this form, a times b to the x. Now growth happens when b is bigger than 1, greater than 1. So this is what we would have to look for. So we'd look for b. If b is 1.1, 1.01, that is still bigger than 1, it would be growth. All right, then for decay, if the value of b is between 0 and 1, then it would be decay. So 0.5, 0.875, 0.9. All of those would be between 0 and 1. So a positive number that is smaller than 1, like a positive decimal. Okay, those would result in decay. And notice for both of them, a is the y-intercept. Now, when we look at transformations of exponential functions, our graph looks, or our formula format of this equation looks a little different. Now, a isn't necessarily the y-intercept anymore here. A's job is to tell us two things. First, it'll tell us if the graph has reflected across the x-axis. So, if A is negative, then the graph has reflected across the x-axis. If A is positive, then it has not reflected. The other thing that A tells us is if our graph is vertically stretched or compressed. So for this, we need to look at the absolute value of A. If it is greater than 1, then our graph is vertically stretched. If our graph, or oh my gosh, sorry. If the absolute value of A is smaller than 1, then we will see that it is a vertical compression. So it is vertically compressed. Then I look at B. Okay, B, as we said, is in charge of growth and decay. So remember that if B, it's always going to be positive, pretty much, or at least when we see it. It's always going to be positive when we see it. If B is larger than 1, then it is growth. If B is between 0 and 1, then it will be decay. Now, H is in a different spot. Instead of just being inside of parentheses, we see that H is with X in the exponent. So recall that when we see X minus H, that means that our graph shifts to the right. If we see X plus H, then it would shift to the left. And finally, we have K. So if K is positive, then that would shift our graph up. If K was negative, that would shift our graph down. So please make notes of this information because it is really important. We've seen this a lot of times before. The job is pretty much the same for A, H, and K as we've seen it in previous units. It just looks a little bit different because of how exponential functions are written down. And of course, we have the addition of this B value. So let's move on and let's see an example. So, So the first thing that we are looking at is A, because I like to go in order from left to right. We'll look at A first. And remember that A is in charge of two things. If it is reflected across the x-axis, and then if the graph is vertically stretched or compressed. Now, 3 is a positive number. So is it reflected? No, it is not, because 3 is positive. Then I look at the absolute value of 3. Okay, because that's my A. I look at the absolute value of A. And the absolute value of 3 is simply positive 3, which is greater than 1. So it would be a stretch. Right? Then we look at B. So here our B is 2. And that tells me if it is growth or decay. So 2 is bigger than 1, so it would be growth. Okay, 2 is bigger than 1, it would be growth. Because if B is bigger than 1, it is growth. Then I look in the exponent to see if there is H. Now, if I don't see that there is something adding or subtracting to X, then there is no H, meaning that there is no shift left or right. And we can't see this, which is annoying. And that says if it moves up or down. All right, and then I look at K, and I have a plus 1 at the end. So my K is positive. We're adding 1 at the end, so it's going to move up 1. Now, we are about to look at the attributes of this graph. Right, so we are going to head over to Desmos to take a look at the attributes of this graph. All right, so in this order, we are going to start with domain. And so when I'm looking at domain, remember that domain is x values. The way that we can use our graph to check out what the domain is picking a point in Desmos and see how we can slide the points. All right, so start from somewhere and then go all the way to the left side. and pay attention to the x value, so the first number in the ordered pair. If I'm looking at that first number, it doesn't look like it's going to stop anytime soon. So if it doesn't look like it's going to stop, it's going to the left forever. And then I do the same thing looking to the right. And even though it doesn't look the same as the other side, I see that that x value is not going to stop. Doesn't look like it's going to stop. So my domain is negative infinity to positive infinity. We can also say all real numbers. Okay, then we have our range, which is all of our y values. So I pick a point, and now I'm focusing on the second number in the ordered pair. I'm focusing on the y. So now if I look at the y going down, seeing how far down this graph goes, I see that y value is getting closer and closer to 1. And sure enough, now it stops moving. Now it just stays at 1, like it doesn't change from 1. So it goes all the way down to 1. And then when I look at the y value going up, I see that it does not stop. It doesn't look like it's going to stop going up. All right, so the way that I'm going to write my range, right, is parentheses 1, comma, infinity. Or y, since we're talking about range, greater than, since these are values above 1, so this is going up, and then we put 1. Now you may wonder, why am I not going to put a bracket here? Why am I not going to put greater than or equal to? And that's because our graph does not touch this line as close as we think it's going to get. If I look, if I zoom in, it is not going to touch. So please keep in mind that that is how we will need to notate that. Then I am looking for my x-intercept. It does not cross the x-axis, so I'm going to put none. Then for the y-intercept, I see that my y-intercept is 0, 4. Yay. Then we've got our asymptote. So our asymptote is this line, this invisible line that our graph looks like it is getting very, very close to, but it does not touch or cross. Okay, so I look at what number is this point getting very, very close to, but not touching. And I see that it is getting very, very close to 1. It's not touching 1, but it gets really, really close to 1. Now, I can't just write 1, all right? I have to specify if this is a y value, an x value, or a y value. Now, since it's the second number in the ordered pair, that is y. So I will be writing y equals 1 for my asymptote. Okay, finally, we are going to look at the maximum and minimum over an interval. So the interval is maximum, it's the maximum on -2, 0. And we're also going to look at the minimum on the interval of -2, 0. Right, so when I want to type the interval in, I cannot type it in like this, like I see it. I cannot type it in like this because it just tells me that it's a list. That doesn't do anything. I want it to give me the shaded region that it's asking about. So I have to type this. Okay, so this tells me that I'm looking at all of the x values in between -2 and 0. So please make a note of this on your paper that this is what you have to use to rewrite the interval so you can see the image. Right now, if I look within this interval, right, I see 2 points, see -2, 1.75 and 0, 4. Now what's important, what we care about with the maximum and minimum is the y value. So my maximum is going to be 4. My minimum is going to be 1.75. Okay, great. That is pretty much it. There are other problems in the packet that you can go through. There's 2 other problems to kind of check your understanding, but this is pretty much all you need to know. There is a quizzes review activity if this is something that you need to like revisit and see more examples of. But other than that, that is it. Bye.